Hello, today we are going to work on the first part of the 4.2 isosceles and equilateral triangle notes. You guys will be able to apply theorems about isosceles and equilateral triangles to solve problems. Today we're going to focus on isosceles triangles. So theorem 4.1, isosceles triangle theorem and its converse. The theorem states, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay? The converse, which we call it, is flipping the two statements, the hypothesis and conclusion states, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if we look at the picture for the original theorem, if you have two congruent sides like we have here, the opposite angles are guaranteed to be congruent. Okay, so these two down here are guaranteed to be congruent. They have to be opposite of the congruent sides. Okay, now these are called base angles, the congruent ones. That'll be helpful later. They are base angles. The congruent sides are considered the legs, and the non-congruent angle between the two legs is called the vertex angle. Okay, so those are just a bunch of vocab terms to help you out when we're talking about isosceles. Keep those in mind. For the converse, if you are given two base angles that are congruent, the opposite sides must be congruent. So in this case, opposite of angle A is BC. Opposite of angle C is AB. So we know for sure, because of the base angles, that those two sides are congruent. Okay? So we're going to take a little T-chart and write a proof here for the isosceles triangle theorem. Recall that you cannot actually use the isosceles triangle to prove this. We have to go in a roundabout way. So we have this isosceles triangle here, ABC. It has a segment, AB, congruent to AC. That means it's an isosceles triangle. We are going to prove that these two base angles are congruent. That is what we are trying to get to. So we have our statements. We always start with our given. So we have isosceles triangle ABC with AB congruent to AC. Okay, the reason there, that's given. It was given to us. Now, it's going to be a little weird. I'm going to come up with some random stuff, but I promise it is necessary. So we are going to make a new point. We're going to call it D. And we're going to say let D be the midpoint of segment BC. So we're going to make a new point here, and we're going to call it D. It's going to be the midpoint. So our reason here is that all segments have a midpoint. That's just something that's true. You could technically use that statement that reason in any proof. It just might not be helpful. In this proof, it is. In 3, we are going to draw a new segment because any 2 points can make a segment. So we are going to draw segment AD. This is just because 2 points determine a line. So we're going to connect the dots there, A to D. All right, step 4. I'm going to say that segment BD is congruent to segment DC. Seems a little weird, but this is just the midpoint theorem. Since D is the midpoint, by definition, these two segments must be congruent. We then know step 5 that AD is congruent to itself. This might be the first time we've seen this. I told you a couple weeks ago, more towards the beginning of the year, that we would see this property when it comes to proofs, and it would seem silly, but we have to state it to make a complete proof. This is our reflexive property when you state that something is congruent to itself. So we have the reflexive property of congruence. This segment is congruent to itself. We need to state that. Now, this proof is a little weird because these last two steps are actually something that we haven't learned yet. We'll actually get to this soon. So don't freak out if you're like, I do not understand what she is saying. That is true. You do not yet know. We have a triangle ADB congruent to triangle ADC. And this is by something called side, side, side. Now, like I said, we have not learned this yet. We will abbreviate it SSS. We will learn this soon. Okay, this is a little bit out of order. It's okay. Don't freak out. Our last step here, another one that's new. We'll get to it. This is that angle BC is congruent to angle, angle BC. Angle B is congruent to angle C, which is what we were trying to prove up here. And this is by something called CPCTC. Once again, we will learn this soon, okay? If you recall from our little proofs we've done in the past, you put a little box at the end so we know that our proof is complete, and we do know for a fact that these two angles are truly congruent. Now, you won't ever have to do that proof again. That's just making us know for a fact that every isosceles triangle has base angles that are congruent. Okay? So in this picture, we are going to name two unmarked congruent angles. So since they need to be unmarked, we will not be marking these two angles because they are already marked. We will look at the isosceles triangles. So we have this isosceles triangle here with two legs that are congruent. This means that the opposite angle, so the angle that does not touch that leg, has to be congruent to the other opposite angle down here. Now, because angle C shares for three different angles, we're not going to actually call it angle C. We do need to call it angle BCA. And our other angle we could just call angle A if we wanted, because it's just angle A, but I'm gonna write it angle BAC. Okay, so we have opposite angles are congruent to each other, the base angles of the isosceles. Part 2 asks us to name two unmarked congruent segments. This one does get a little tricky because one of them is actually marked. Based on these congruent angles, the opposite sides have to be congruent. So the angle does not touch its congruent opposite sides. It is across the triangle from it. That means that segment CB has to be congruent to segment DB. Okay, these opposite sides have to be congruent. These also happen to be congruent to BA then, but only because we have two isosceles triangles here. Okay, now we can use the isosceles triangle information to solve with information inside of a triangle. So for example 2, it asks me what the value of x is. I know this is an isosceles triangle because there are two congruent legs. That means the opposite angles have to be congruent. The one right now is marked. It is the vertex angle. So because the two angles, base angles, are congruent, this unmarked angle is 28 degrees. Now, hopefully you recall that a triangle has 180 degrees in total. So I am just going to now add these three angles, 5x plus 9 plus 28 plus 28 has to equal 180. We do some fairly simple math, combine like terms, we get 5x plus 65 equals 180. We solve. It does not ask for a specific angle measure or anything, so we can just get our answer after we divide, which is x equals 23. Okay, the second problem. These look very similar. This is a U-try, so if you want to pause me, you can. These look very similar, but they solve very differently. Okay, so make sure you know what information you're given and how you are going to solve. So in this case, the second problem, you'll notice that both of these angles are across from the congruent legs, which means they are the base angles and they are congruent to each other. We don't know anything about this vertex angle, and we're not even going to worry about it. We are just going to go ahead and equal these to each other. So negative 4x plus 9 equals 8x minus 3. We solve. I'm going to add 3 to both sides and add 4x to both sides. We get 3 equals, why did I write 3? We don't get 3. We get 12 equals 12x. We divide by 12, and we get that x is equal to 1. So guys, you'll notice we solved super differently. This one, we were given a vertex angle and a base angle. So we used that information to add them all and equal them to 180. The second problem, you are just given two base angles, which means they are congruent to each other, which means they just equal. So really pay attention. How do you solve? What are you given? Example 3, we are now given side lengths. Very similar idea, except you will never use 180 to solve for side lengths unless, for instance, a perimeter happens to be 180. Okay? You can't assume anything about side lengths. So it asks, what is the value of x? What are the lengths of all three sides of the triangle? So not just solve for x, but also plug it back in. So for this problem, based on the congruent base angles, we know that the opposite sides have to equal. So I am going to set these two things equal to each other. That's pretty much our only option when it comes to solving for sides. Set the two congruent legs equal. So we have x plus 20 equals 8x over 3. This one's a bit tricky to solve for. I'm going to multiply by 3 on both sides. Then I will have to distribute this 3 through. Don't fall into the trap of just writing 3x. It is 3x plus 60 equals 8x. When you finish solving from here, once you get that first step done, it's not too bad. You get that x is equal to 12. So that's one part of the problem. It then asks us to plug it back in. So I'm going to plug in for PQ first. So I just take 6 times 12 minus 12. This gives me 72 minus 12, which is just 60. So PQ is equal to 60. PR, I'm just going to plug in 12 for x. So PR, very simple here, is 32. And then some of you might already know what RQ is, but I'll go ahead and plug it in. 8 times 12 divided by 3. I just did this in my head. You can do 8 times 12 if you want. RQ is also equal to 32. Okay? Now, like I said, some of you might have already known what RQ was. It's just congruent to PR, so you didn't really even have to solve that one because you already knew what PR was. So RQ is the same. All right, go ahead and pause me. You guys try the you try. Find the value of x. What are the lengths of the 3 sides of the triangle? I'm going to go ahead and solve this so when I come back on, it will already be solved. So make sure you're taking the time to solve it on your own. Alrighty, so when I solved this one by equaling my 2 legs to each other, I ended up getting that x is equal to 1.5. You could also write this as the fraction 3 over 2. Both are totally fine. This one does not have any labels for our vertexes on our triangle, so I just went ahead and wrote out all 3 side lengths, 11, 11, and 14. There's nothing really to label them, so there they are. Theorem 4.2 is our next one. If a line or a line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So recall perpendicular bisector, it crosses at 90 degrees. That is the perpendicular part. We've been talking about that. And it is the midpoint between 2 points, okay? So these 2 segments have to be congruent. That's the bisector, cut in half. And then perpendicular means it's 90. Okay, so perpendicular bisector, if you break it down, is, bisector, 90 degrees. It is also midpoint. So remember, this vocab term explains exactly what it is. And if you want to think bisector, this is cut in 2. Okay, so if we look down here, it has to bisect the vertex angle. That is your non-congruent angle. It's the non-base angle. If it bisects that and it's an isosceles triangle, we know for sure. Then we know that we have a perpendicular bisector on the opposite side. This means that these 2 are congruent and this is crossing at 90. Okay, which they pictured for us over here. I just drew it on the first one. So we're going to use that in example 4. Example 4 states a prefabricated house is delivered to a foundation in 2 symmetric halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. We're going to draw a diagram to represent the roof section. So that's this section here. Okay, you could do it on the picture theoretically. Might be a little difficult though. So I'm going to draw my diagram. It is an isosceles triangle. So we have A, B, and C, and I'm just going to fill in everything I know. I know it's split down the center here. Sorry, my picture is not the greatest. It's also marked that these two are congruent. It's marked that these are both 16 feet, which means they are also congruent. And I believe we can fill in one more thing. We have to use our theorem 4.2. So segment BD, we'll label this D here, is the perpendicular bisector of segment AC. So both AD and CD are equal to 14 feet. If you guys look down here, see how this whole segment is 28 feet? Since we know that these two must be congruent, we have a perpendicular bisector here. Each of these are 14 feet. Okay, you'll notice right here, it looks the same. We've got congruent angles up here through the vertex. So we have the 14 midpoint distance there. Okay, now we have to find this height here. I'm going to call it H. We're going to use the Pythagorean theorem to do it because these are both right triangles. Okay, just pick one to look at. So I know that H is one of my legs of my right triangle. So H squared plus 14 squared has to equal 16 squared. This math tells me that H squared plus 196 is equal to 256. We solve. H squared is equal to 60. And when we take the square root of this, I am going to just go ahead and get a little bit of a decimal. It's about 7.7 feet. Okay, now, here's the deal. Actually, before I do that, I'm going to draw us out that right triangle so you guys know where I got all this information. H was here, 14 is here, 16 is here. That's how I solved my Pythagorean theorem. If you're not sure about Pythagorean theorem, here is that theorem. A squared plus B squared equals C squared. C is your hypotenuse. The hypotenuse is always the longest side, and you can find it because you know it is across from the 90 degrees. So that's why I put 16 where it is. So it wants us to analyze now. If we look back at our picture, the base part of the house is 10 feet tall, which means if I take 10 feet plus 7.7 feet, which is the height of the roof section, that is 17.7 feet. This house will not fit under the bridge. Okay, so we have to write that the house is approximately 17.7 feet tall. The trucker should plan a different route to the site. Or he might just end up smashing the house, which would be very, very sad. All right, last do try of this video. You're going to use the figure shown. You're going to find the angle measure of RSQ. That is this angle right here. I promise you it is possible. And you are going to find the length of PR. So this whole length here, which is definitely a little easier. Pause me, try and answer it. Okay, hopefully you pause me. I'm going to find RSQ first, this angle. To do that, I know that this angle right here has to be 31 degrees. This is an isosceles triangle, so the opposite angles are congruent. I also know based on this bisecting SQ here, that this is a perpendicular bisector, meaning that that is 90, which means to find this last angle here, I can just take x plus 90 plus 31 and equal that to 180. I combine like terms and I finish solving by subtracting 121. This gives me that x is 59 degrees. Okay, there are other options to solve for this. Totally fine. For instance, I could have taken 31 plus x equals 180. That's if I wanted to look at this whole entire triangle. And we know all the angles equal 180. You solve, you're still going to get the same thing. 59 is x, or the measure of angle, which I should probably write out actually. The measure of angle, RSQ, because that's really what I was solving for. And then PR, since we already decided that this is a perpendicular bisector, I know that PQ is also 4 units, so I just add PQ and QR, and I get that PR is 8 units. All right, tomorrow we will do the second part of this. For now, if you have extra time, go ahead and work on the next worksheet in your packet. Have a great day.